Students, today we are going to talk something about the moment of inertia. Already from majority of the students, they have attended the online classes and different faculties of physics department have taken a personal care for individual students to learn. In spite of that, some students they miss the class, and a few cluster of teachers within the department in a short time want to give some ideas about this moment of inertia and what are the topics missed, and it is only a supplementary help, nothing like attending personally, but we are trying to do as much as possible. And if there is a conceptual mistakes or expressing some ideas in a not proper way, please we ask you to neglect all that. And I am very much thankful to Professor Dr. Ashwini Madam, Associate Professor in Physics. She has given all type of help and distribution of marks in this topic, and all department members also helped here and there. Only I am doing the comparing job, and I may be giving only 60 or 70% of whatever they have said. And I advise all the students or the viewers to go through the textbooks and watch different videos it's uploaded in the university websites and discuss with other colleagues and all that, and give a constructive comments for further improvement. And we are not taking a big movie or like Bahubali or something like that with a lot of professions, with a minimum accessories. We are doing it. Before starting this, just have a look on this video clip.
Or we could rotate it onto its side, like this. Intuitively, we can, let's say we have a plank, which we would like to use to cross a canal. It has a rectangular cross section, and so we could either use it like we have done here, or we could rotate it onto its side, like this. Intuitively, we can tell that the plank will be stiffer if the load is applied to the shorter side of the cross section. Some cross sections are much more efficient at resisting bending than others. The further the material is spread from the bending axis, the stiffer a cross section tends to be. The cross section on the right has more material located far from the bending axis, and so is better at resisting bending, even though both cross sections have the same area. This concept of resistance to bending can be quantified by calculating the area moment of inertia, which is also sometimes called the second moment of area. The area moment of inertia reflects how the area of a cross-section is distributed relative to a particular axis, and so is a measure of how much resistance the cross-section has to bending. The I-beam locates the majority of the material as far as possible from the bending axis, and so is a very efficient cross-section. This is why it is so commonly used in construction. In this, to take a detailed look at the area moment.
Now here what we have studied, if I have the area like this or the same area is same, but this is a different configuration. And now this area remains same, but which has more strength? These are more strength. Understood? And which is more strength are this, like this. Suppose it can withstand the weight of 100 kg. 101 will break. Here 150 kg. Here 500 kg can withstand. Therefore, this configuration has more strength. That means entire weight act on this axis. Therefore, it is like this. All person work for 8 hours. Security guard, office administrator, a professor, but salary is different, is it not? 8 hours is constant, but salaries for a security guard less. For an officer, it will be 5 times. For the teachers or professors, maybe 10 times. Therefore, in a same thing, person is same, area is same. How you utilize and what type of configuration, how you configure yourself, it depends. Therefore, in a given time, how much time you spend on your studies and getting maximum marks and increasing your academic strength is more important for your future life. Here, we are going to study the chapter moment of inertia. I is a symbol for moment of inertia. Why we have to study? The study is what? To increase the strength. The aim is what? Strength of the material and to reduce the cost. Now here, this much portion I can cut out. See, instead of using a metal beam of this type, I can cut out so much portion, but not same area. Lot of portions of material we can save. With the minimum materials, we can have the maximum strength. For that, you have to study all possibilities. Right? You take a paper, and keep it on 4 tumbler, 2 tumbler, 2 glass, a tumbler. You keep a paper, ordinary paper, and upon that you keep another tumbler. What will happen? It will sink. Instead, what I do is this: I bend the paper like this. Right? Understood? See, like waver type. Then I keep the paper here. The tumbler will stand. Pour some amount of water. It will withstand the weight because it struggle itself. It underwent lot of strain and stress. Your ordinary person, ordinary youth, you are an educated youth. Therefore, there is a lot of difference between uneducated and uneducated. Therefore, most of our educational qualification are decided by our marks. You may call it foolishness, but marks give the confidence. How to get the marks? You have to study the portions, and self-discipline is very, very important. Now carefully go through that. And what we are doing in the class and what I am trying to do is called some sort of innovation. Doing the same thing in a different way. You also start doing a different video lesson and send to the college, upload it. Right? Therefore, you see another video now.
A solid sphere, a solid cylinder, and a hollow cylinder having same masses are rolled on a ramp. Which one will reach the bottom first? Let us check. Sphere reaches the bottom first. Do you know why? To know this reason, you have to understand what is moment of inertia.
Now, in an inclined plane, I got on solid sphere. Solid sphere, a rod, a solid rod, and a ring. See, the mass remains same. All having a equal mass. Okay? Equal mass. Which will reach first? Here, this is the first one. It will reach first. This is second. This is third. Therefore, mass remains same, but speed. This is because moment of inertia is less. Therefore, inertia is something try to stop you. Because today you want to get up at 5 a.m. But 5:15 you'll get up. What is the cause? You have an inertia of rest. You are overcoming the inertia. You are applying a force. Understood? Your body, it kept at rest, it remain at rest. And if you apply a force, what is the inertia is rest. Now the body begins to move. That means inertia changes. What is inertia? Motion. Therefore, a moving body want to come to rest, or a body which is at rest want to move, we have to apply a force. Therefore, here in this case, the linear force, something changes the inertia. Therefore, what is the force? Force is the one which changes the inertia. Inertia is what? State of being. I want to see every day a person every individual grow in terms of biological growth is there, intellectual growth is there. In 3 months or 4 months, how much intellectual growth is you have acquired? That you think of, right? Now, to understand this topic, you need certain concepts. If you want to know the trigonometry, you want to understand, you need certain formulas, sin theta, cos theta, tan theta, and all that. If I want to know the calculation, multiplication table is important. Without knowing the multiplication table, you don't. It's very difficult to calculate accountancy or any calculations. See, therefore, first certain concepts, it looks a bit nonsense, but you have to mug it up. Then later you know the values. Like most of these poems, ಈ ಗಾದೆಗಳೆಲ್ಲ ಓದ್ತೀವಿ, ಬಟ್ ಅದ್ರ ಮೀನಿಂಗ್ ಯಾವಾಗ ಗೊತ್ತಾಗುತ್ತೆ ನಮಗೆ? ಇನ್ ಅ ಲೇಟರ್ ಸ್ಟೇಜಸ್. ಬಟ್ ಫಾರ್ ದ ಕಿಡ್ಸ್ we make them to mug up. Most of this moral, what is the poem and moral, what is it, what do you call, songs and all, they ask the children to mug it up. But the later stage you will understand. The same way here also, certain concepts are there, you may not understand at that meaning. Area of, see, pi r square, area of a circle. At the 7th standard level, if you ask me, it's very difficult to do it. I need integration, which comes in second PUC. But there are different methods of teaching nowadays. But in our time, it was very difficult. How you got it? What is called pi? Nobody was explaining us. Now you got a lot of teaching aid. Anyway, before starting that, I'll give certain concepts on moment of inertia. Now, first you must know what is called rigid body. Rigid body andre eno? Body. You take a rigid body, okay? I'll locate 2 points, P1 and P2. Measure the distance D. D is the distance. Distance may be 7 centimeter. I apply a large force on it. External force. Heavy force. In spite of applying force, normally what? If it's a rubber, the material is made up of rubber, the distance decreases. Or if I apply a force on this direction, the distance increases. But according to the definition of rigid body is the one where the distance between the 2 points will not alter or will not change whatever the external force is applied. A rigid body does not undergo any change in shape also. There is shape change agalla, volume change agalla, distance change agalla. It is non-deformable. Andre shape change agalla by an external force applied on it. When you a rigid body does not undergo any change in shape, in volume, that is non-deformable when an external force are applied on it. Right? Rigid body. ಕೆಲವರು ನಾವು ಎಷ್ಟು ಅಡ್ವೈಸ್ ಮಾಡ್ತಾರೆ ಹುಡುಗರು, they don't change their characters. They are very rigid in their attitudes. We have to listen, we have to change. Change is only the life. Right? Therefore, coming to that, there are here, what is a rigid body ಅಂತ ಹೇಳಿದ್ರೆ, for 1 mark you have to tell. See how I have written. A rigid body does not undergo any change in shape and volume. That is non-deformable when external force is applied on it. ನಾನು ಇದನ್ನು ಹೇಳಿದ್ದನ್ನು ನೀವು ಪಿಕ್ಚರೈಸೇಷನ್ ಮಾಡಬೇಕು. Therefore, whatever you read from the textbooks, you put a picturization. Think that you are making a movie, or you are a cartoonist, or you are making animations. Think it that and have an imagination power. Definitely, for that you need not have a art. For art at all, it comes in your mind. It is not by practice. Keep doing something, you will get it off. Right? Therefore, from what you are going to sentence or the picture you are making, convert it to sentence. Okay? This is a different art. Anybody can do it. It needs little set of practice, that's all. Okay? For any rigid body, there are 2 types of motion. One is translation motion, next is rotational motion. Andre translation motion and rotational motion andre, you roll a ball, right? The ball is moving in this direction, which on the ground it is moving in this direction. That is called linear velocity, that's called translation. And as well as it is doing a rotational motion as well. It is doing a rotational motion. Rotation is not angular velocity. Can you follow? Linear velocity and angular. Suppose you take a wheel right? The wheel is rotating with an axis, right? It is having a linear velocity and angular velocity. What is the direction of angular velocity? See, the vector, linear velocity vector is this direction, angular velocity vector is that direction. ಇವಾಗ ವೀಲು ಈ ಥರ ಇದೆ. If the wheel rotates like this angular velocity is what? Upward, anti-clockwise direction. Anti-clockwise, see, anti-clockwise. Anti-clockwise is positive. Omega is this one. Really. Suppose when the wheel rotates like this, right? Omega act downwards. Can you follow? Omega act downwards. But what about the particle? You take on particular particle P, right? What is the velocity? Linear velocity along the tangent to the disc or circle. Understood? ಇದರಿಂದ ಏನು ಗೊತ್ತಾಗುತ್ತೆ? See, this is omega, this is particular point, this is r. R is the radius vector ಅಂತೀವಿ ನಾವು. V is this. Therefore, V cross R is equal to omega, correct ತಾನೆ? ಇವಾಗ if you take a plane, right, this is one vector, this is one vector. See, vector can be transmitted anywhere. I am transmitting this to O because as long as it is parallel, nothing will happen. This is R, this is V, parallel to this, right? Therefore, two vectors are inclined at an angle theta. Omega is a vector which is perpendicular to both V and R. Dandre R is one vector, V is one vector, theta is an angle, and omega is a vector which is perpendicular to both. Therefore, V is equal to V cross R or R cross V or whatever it is. R cross V, I think. R cross V, anti-clockwise direction. R next to V. From here, from origin R and V, R cross V. See, sometimes this concept, we do some mistake in this calculation or mathematics. We are not mathematician. You have to refer, right? Don't find fault on it. Okay. ನಾನು ಹೆಂಗೆ ಬರ್ಕೊಂಡೆ ನೋಡಿ. Rigid body has two types of motion, translational motion and rotational motion, right? See, in PUC you have studied, you take one circle, O is the origin, and you take 2 points A and B, right? R is the radius, this is the length, S. S is equal to arc length. It subtend an angle theta, right? Theta ಜಾಸ್ತಿ ಆದರೆ S ಜಾಸ್ತಿ. If theta increases, if S increases, theta also increases. S is directly proportional to theta. S is equal to some constant to theta. The constant ಏನು? Radius. S is equal to r theta, right? This is arc length. S is equal to r theta, right? The same way here, suppose ಈ laminar ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. This is a sort of a laminar. Laminar means a cardboard or a blade or whatever it is. This is axis of rotation, right? This is axis of rotation, and A is the point. A is the point of consideration. You are taking one particular point which is at a distance of r. Now, if it rotates, when t is equal to 0, it was here. After some time, it comes to point B. R remains same. Theta is the angle. Now what it is? Angular velocities in this direction, perpendicular to both this. Now how much it is covered? Yes. Now ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? The velocity is this direction. Here the velocity is this direction. Aerial view. What is called aerial view? I look like this directly. ಮೇಲಿಂದ ನೋಡ್ತಾ ಇದ್ದೀನಿ ನಾನು. I am looking from the directly here. Now, therefore I am recording in the aerial view. Is it not? ಆ ಥರ ಇದ್ದರೆ ದಿಸ್ ಇಸ್ ಓ ಹಿಂಗಿರುತ್ತೆ. ಯು ಅಂಡರ್ಸ್ಟುಡ್? ನೌ ಎ, ದಿಸ್ ಇಸ್ ಆರ್. ನೌ ವಾಟ್ ಇಸ್ ದ ವೆಲಾಸಿಟಿ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್? ಫ್ರಮ್ ಎ ಟು ಬಿ ಇಟ್ ಹಸ್ ಕಮ್ ಹಿಯರ್. ನೌ ವಾಟ್ ಅಬೌಟ್ ದ ವೆಲಾಸಿಟಿ? Velocity is tangent to the arc, right? At this point, V. Understood? Velocity, magnitude of the velocity is same, but directions are different. Therefore, ಇದು V1 ಆಗುತ್ತೆ, ಇದು V2, where V1, magnitude of V1 equal to magnitude of V2 is V itself and theta, and this is S. Therefore, S is equal to R theta, Suppose divided by T, what do you get? Distance by time. This is distance by linear distance by time. This is called linear velocity. Linear velocity. Now, this is called angular velocity. Linear velocity denoted by V. This is our angular velocity, omega. Or this is a vector quantity, this is also a vector quantity. This acts tangent, this acting upward. Nodi, idu mele ide nodi. It is upward. That means coming out. Idu hing tirugidre enagutte? It is going down. Avaga ಏನು ಮಾಡಬೇಕು? Cross ಆಗಬೇಕು. Omega is down. If it is going upward, omega is what? Dot. Can you follow? Therefore, at present, therefore, what is the vector notation? Also important here. Vector notation, V is equal to omega cross R. Omega cross R. R, why R cross omega? It depends upon, say, R cross omega depends upon clockwise or anti-clockwise, right? If it rotate like this or it rotate like that, it depends. Okay? V is perpendicular to omega R. Similarly, what? Here, omega is what? Perpendicular to R and V. Remember. You understood? It is perpendicular to V and R. Therefore, what is angular velocity? Linear angular velocity is equal to angle covered by time taken. Omega is equal to theta by t or d theta by dt. However small this interval may be, that means what? If it covers equal angle in equal interval of time, equal angle in equal interval of time, however small this interval may be. Now, whatever I am telling in sentence, I am writing in the mathematical form. What is uniform angular, instantaneous angular velocity? Right? Instantaneous of angular velocity is what? It covers equal angle in equal interval of time, however small this interval may be. Another limit anta bakariti now. Can you follow? Therefore, omega is equal to d theta by dt. These are the terms. When you read the textbook, you will encounter all this type of equations. What is angular acceleration? Angular acceleration. Linear acceleration is what? V is equal to R omega. You know this, right? Linear velocity. That means R theta by t. That means every second, say suppose c is equal to every second, it covers 30 degree. Every second. Suppose fan fan or whatever it's our vehicle. Every second radius is constant. Okay, every second. Therefore, V1 is equal to R, T is also constant every second. Suppose I increase the fan current, I will send more current, right? More amount of current. What will happen? R, instead of covering 30 degree, it covers a 45 degree for every second. That means every second it sweep 30 degree. Now I increases the current, that means velocity increases. Speed increases, angular velocity increases, 45 degree, 45 degree. Further I increase more, then what happens? It covers 90, 90, 90 and 90. This is V3. Now I increase the current more. What will happen? 180, 180, 180. Like this what? Therefore, if V2 is the final velocity, V1 is the initial velocity, change in time, T2 minus T1. This is V. V is equal to R omega 2 R omega 1 divided by T2 minus T1. R is constant. Omega 2 minus omega 1 by T2 minus T1. This is called angular acceleration. This is a vector quantity. Therefore, this also angular acceleration is equal to R d omega by dt. Again, however small this interval may becomes. Therefore, if the wheel, right, if the speed increases in anti-clockwise direction so fast, angular acceleration is like this direction, upward in the anti-clockwise direction. If the speed decreases, angular acceleration is negative. This is positive. Positive is upward, angular acceleration is negative. Therefore, alpha is equal to positive if it is anti-clockwise direction. That means alpha increases upward. That is called anti-clockwise direction. Alpha is equal to negative. That means alpha decreases. Can you follow? Now, what is acceleration? See, this is angular. This is angular. I did a mistake here. This is called alpha. What is linear acceleration? Linear acceleration is equal to r times alpha. Therefore, alpha is what? This is alpha. Can you follow? Alpha is equal to d omega by dt. Therefore, v is equal to r omega, a is equal to r alpha, and s is equal to r theta. See, these are all correspond to linear motion. All these correspond to angular motion or circular motion. Yes, linear distance. This is angular angle. V is the linear velocity. This is angular velocity. A is the linear acceleration. This is angular acceleration. Therefore, remember this. These are all one correspondent. V is equal to u plus at andre enagutte. This is initial velocity. This is a final velocity. This is initial velocity. Acceleration to t. That is final angular velocity, initial angular velocity, alpha and t. This is the correspondent you have to do it. Can you follow? S is equal to ut plus half at square andre. Instead of s you have got theta. This is initial angular velocity plus half acceleration ಬದಲು alpha ಆಗಬೇಕು t square. Force is equal to what? Mass into acceleration. This is called linear force. Now this is the problem. This is angular acceleration, you know. ಈ ಫೋರ್ಸ್ ಅಂದರೆ ಲೀನಿಯರ್ ಫೋರ್ಸ್. ಈ ಲೀನಿಯರ್ ಫೋರ್ಸ್ಗೆ ಆಂಗುಲಾರ್ ಫೋರ್ಸ್ ಅಂತವೆ. ದಿಸ್ ಈಸ್ ಅ ಲೀನಿಯರ್ ಫೋರ್ಸ್ ವಿಚ್ ಮೇಕ್ಸ್ ದ ಬಾಡಿ ಟು ಮೂವ್ ಇನ್ ಎ which direction? Linear direction. And here angular force. This is the force makes the body to rotate. Right? A constant force is required to make a body to maintain the linear motion. There is a constant angular force, or is also called torque, is required to make a body in a rotational motion. ಆಮೇಲೆ ಇದು ಲೀನಿಯರ್ ಮಾಸ್ ಅಂತೀವಿ, ಇದು rotational mass. This rotational mass is called moment of inertia. ಒಂಥರ ಕಾನ್ಸೆಪ್ಟೇ ಒಂಥರ ಇರುತ್ತೆ ಇದು rotational mass, moment of inertia. It is a high concept. Moment of inertia is called rotational mass ಅಂತ ಹೇಳ್ತೀನಿ. ಅದು ಎಷ್ಟುವರೆಗೆ ಕರೆಕ್ಟ್ ಅಂತ ಯು ಹ್ಯಾವ್ ಟು ರೀಡ್ ದ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಆ್ಯಂಡ್ ಡಿಸ್ಕಸ್ ವಿತ್ ದ ಫ್ರೆಂಡ್ಸ್ ಆ್ಯಂಡ್ ಯು ಹ್ಯಾವ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್. ಇಟ್ ಕಮ್ಸ್ ಬೈ ರಿಯಲೈಸೇಷನ್. ನಾನೇನು ಹೇಳಿದ್ದೀನಿ, ವಾಟ್ ಐ ಹ್ಯಾವ್ ಸೆಡ್, ಮಾಸ್ ರಿಮೈನ್ ಸೇಮ್, ರೈಟ್? It is a sphere or a rod or a ring. Which one reach fast? Sphere reach fast because it has less moment of inertia. Right? Therefore, these are the things you have to analyze, and by the end of the chapter you will understand what the moment of inertia means. ನಾನು ಆವಾಗನೇ ಹೇಳಿದ್ದೀನಿ, why you have to study this chapter? To increase the strength of a given material and reduce the cost. Right? Therefore, that is just I have shown 2-3 videos and all that. And suppose a solid sphere or a hollow ring which has more strength, that is another problem. This has got more strength. This much material will taken out. Therefore, with this solid sphere you can make 2 such rings with more durability and constant. You understood? If you are an uneducated, you will be doing this and lot of loss of energy, lot of cost and all that. Therefore, it is better to be an educated person. For an education, you have to slog like anything and sacrifice your time and self-discipline you have to impose on yourself. Right? Suppose a body, see, a laminar body, got it? This is axis is like this, and how to like in the 3-dimensional, I'll take it. The 3-dimensional, image I'll take this. There is one particular point P, and O is the origin, and R is the distance from this point, and it is moving like this. You are taking a irregular body and rotating it with respect to this axis. Now there are two types of motion. One is what? Tangential velocity and radial velocity will be there. Two type of velocity, tangential velocity and radial velocity. It is towards the center. Similarly, there is an acceleration called radial acceleration and transverse acceleration. See, you may not understand at this present. When I start, it will take 1.5 hours on this. Therefore, what is that means Vt is acting in this direction, we are acting in this direction. Then what is the resultant? Resultant in this direction, V. The same way, AR acting in this direction, AT acting in this direction, the resultant is CR, A in this direction. Right? V. Therefore, V is equal to Vt, suppose x-axis I, or V R, here this unit vector T, this is unit vector this direction. You can write like this. Or Vt plus Vr is equal to V. And this looks like mathematics, it's a little bit difficult, but you remember this too. AT, transverse acceleration, this is called transverse acceleration, is given by R alpha. This only I derived it. AT is equal to R alpha. And radial acceleration, this is towards the center, is equal to omega square R. Remember this. These two you have to remember. This I will give the proof later at present. Similarly, V is equal to R omega anta barididinalva. This is Vt is equal to R omega. Can you find out VR? Just you try on your own. Refer some books. Therefore, V is equal to square root of Vt square plus Vr square. A is square root of At square plus Ar square. See, this is only for competitive exams and all. It is useful for you. It is only for the students who want to pursue a higher studies. And no doubt, if you spend 15 minutes or 20 minutes extra, you will also equal to this. What is the difference between a rank student and what third class students? That fellow spend 10 minutes extra than you, more than you. But in a long run, the earning will be 100 times than what. You want to become a peon or principal, you decide. The 10 minutes decides everything. Please. Therefore, what I advise is, whether it's comes for examination or not, just go through that. It is a challenging, right, to learn all that. Therefore, then what is moment of inertia? Andre ಏನು? A body free to rotate, its axis cannot roll all by itself. ಇವಾಗ ಒಂದು ಆಕ್ಸಿಸ್ ಅಲ್ಲಿ ಇದು ರೊಟೇಟ್ ಆಗಬೇಕಾದ್ರೆ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಟು ಡೂ? ಐ ಹ್ಯಾವ್ ಟು ಅಪ್ಲೈ ಸಮ್ ಫೋರ್ಸ್. ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಸಮ್ ಟಾರ್ಕ್. ದಟ್ ಮೀನ್ಸ್ ವಾಟ್ ಇಸ್ ಟಾರ್ಕ್? ಟಾರ್ಕ್ ಮೊಮೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್, ಇದೆಲ್ಲ ತುಂಬ ಕನ್ಫ್ಯೂಷನ್. ಮೊಮೆಂಟಮ್ ಏನು, ಮೊಮೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಅಂತ. ಸಿ, ಮೊಮೆಂಟಮ್ ಮೀನ್ಸ್ ವಾಟ್? ಮೊಮೆಂಟಮ್ means product of mass and velocity. This is called quantity of motion. Quantity of motion. See, quantity of motion is product of mass and that is called P. P is equal to mass and velocity. This is responsible. Change in momentum or rate of change of momentum is directly proportional to the applied force. This is Newton law. This is linear force. Linear momentum. Moment andre what is called moment? What is called moment? There is one point, right? O is the fixed point. This is called fixed point. And you are applying a force here. Linear force. Force into perpendicular distance. That means this, suppose this is a door. Think this is a door. This is a hinges here. Then you are applying a force. What is the tendency of the door to rotate in what? Anti-clockwise direction. What is the moment? Moment of a force. This is called moment of a force about O. Moment of force is a vector quantity because it is going anti-clockwise direction, positive. This is what? Magnitude of the force and perpendicular distance. Right? Moment. ಇವಾಗ ಈ ಥರ ಇದೆ ಒಂದು ಬಾಡಿ ಇದೆ. It's a rigid body. Right? I have one fixed point here. This distance d1, this is distance d2. ಅರ್ಥ ಆಯ್ತಾ? I am applying a force here. F1. Here F2. Two forces. This is the fixed point. This force tends to rotate the body in this direction. This force tends to rotate the body. If any one of the force is more, this tendency of rotation is equal to 10 in force per perpendicular Newton meter. This tendency is what? This is 15 Newton per meter. ಈ ಕಡೆ ಇದ್ರೆ which direction rotate? This is overcoming this. What is the net? 15 minus 10. This is negative 15. This anti-clockwise, this is positive. This is clockwise, this is negative. What is the net? 5. Therefore, it want to rotate like this, it want to rotate like this. Finally, the entire body rotates. Suppose the body is not at all rotating. Andre, you know, what is it? Clockwise moment is equal to anti-clockwise moment. You have studied in PUC. Therefore, F1 d1 equal to F2 d2. Anti-clockwise moment is equal to clockwise moment, or F1 d1 minus F2 d2 is equal to 0. ಇವಾಗ see now this is one dimension, is it not? Now take a two dimensions. ಇದು AB, ಇದು AP, right? In a laminar, this is F1, this is F2, this is a fixed point. ಆಮೇಲೆ ಇಲ್ಲಿ suppose C and D ಕೊಡೆ ಥರ ತಿಳ್ಕೊಳ್ಳಿ, right? Here F3, this is F4, and again like an umbrella, no? Your spokes, you are applying different forces. What will happen? Here different points. This is O. A lot of forces are acting downwards, right? Different distance. Think about the situation. Now this is not rotating means what? Algebraic sum of the moment, force into distance, is equal to 0, or algebraic sum of the moment is equal to 0. Either x1, x2, x3, x4, they can put all that. These are things in analysis. Therefore, what you do is, moment of inertia is the body. What is torque? Torque andre force into perpendicular distance. Therefore, if your body want to go in a circular orbit, right, continuously, torque is required. If your body want to go in a linear motion, linear force is required. If a body want to continue to stay in that in inertia andre rotational inertia, torque is required. Therefore, the greater moment of inertia of a body is the greater torque, or couple antare ಕೆಲವು couple required to produce the angular acceleration. Or but ivaga now it is rotating with 30 degree per second. Now what happens? I apply more torque. What will happen? 45 degree per second. Next 60 degree, 75, like that every minute. Now 15. That means what I am doing? Angular acceleration, right? That means angular acceleration increasing, which is responsible for acceleration.